let us look at the tangent graph here and talk about how A, B, and K affect this graph. First, let's understand this graph. First of all, the tangent graph always starts at the midline, right here. If you didn't know, that right there is the midline. So it starts at the midline, all right, and then over here at the end of one cycle, it hits the midline again, and then it hits at 2 pi the midline once again. And if you look at this carefully, you will notice right here is actually one cycle or a period of tangent. 2 pi is 2 periods of tangent. Where with a sinusoid, 2 pi is 1 period, but with a tangent, it actually cycles through at pi. So your period is pi. All right, there's some other interesting features about tangent I want you to realize. This dot right here and this dot right here. What you'll notice is those dots are kind of like your amplitude, which we'll call our vertical stretch. You'll hear in a second. And then right here in the middle, well, this is an asymptote because tangent is undefined at pi over 2. If you think about the unit circle, you will recognize that. Now, I want to put a little dot here just so you see it. There's really not a dot there. But if you act like there's a dot there, look at this. Do you notice that looks like a sine graph? So to graph these, if you really look at it carefully, what you kind of have is a sine graph right there in dots. But instead, you go up against an asymptote, and you go right here against an asymptote. And then it repeats again. So that's kind of what tangent looks like, generally speaking. Again, that's not a dot of it. All right, so what does A give us on tangent? Well, A normally, for sinusoids, gives us our amplitude. But there is no amplitude on tangent. Tangent doesn't have any max or min. It keeps going up and keeps going down. So it's not an amplitude. So what it is what A has always been. A is your vertical stretch. Every single graph we've done so far this year, A was your vertical stretch. And A also tells us if it flips or not. So two things A tells us. How is it stretching and how is it flipping? All right? So here, your stretch is 1. So this dot could go up, 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 up. So vertical stretch is really close to amplitude. This dot right here, you'll see, ends up being your vertical stretch. You'll see as you get farther into other graphs. Now, B. What is B? Well, with sinusoid, B gave us our period. And with these tangents, it's the same thing. B creates your period. Now, it creates the period. So how do we create the period? Well, with a sinusoid, you created the period by taking, to get the period in a sinusoid, you took the normal period of 2 pi for a sinusoid and divide by b. But to get your period, here your period's pi, so you're going to take pi and divide by b. Once again, if this was a sinusoid, it'd be 2 pi divided by b for your period. But since it's tangent, as you can see, it repeats itself at pi. It's pi divided by b. So this is really important to keep track of. Tangent has a different period generator. But b is the same as a sinusoid in that it creates the period, just at a different rate or a different pace than sinusoids. Lastly, k. K is the same as before with sinusoids. K is going to be your midline, also known as your vertical shift. But we're going to call it midline because that's what we called it for your sinusoids. And the equation for your midline is always going to be y equals k. Once again, your period is calculated by doing pi divided by b. And your A is not your amplitude, it's how it's stretching vertically, and it also tells if it flips or not. And tangents will always have an asymptote down the middle of them. I want to write the midline, vertical stretch, and period for this right here. Well, your midline is always going to be that number at the end. It's your vertical shift. So this number is going to be your midline. No matter if it's a tangent or a sine, they're all the same. All right? Now, vertical stretch is the same thing as your amplitude for a sine graph. So for your vertical stretch, it's this number in front. So that'd be it right there would be a 1. Now, why didn't I put -1? Well, negative means it's flipping. So I'm going to put the word flip, even though for this particular problem, flip is not necessary. It's just once the vertical stretch. But I want to put flip because if I were to graph it, I want to reference that this is going to be upside down. So that's just more of a reference point, but your vertical stretch is still a 1. It's just a stretch downward instead of upward. All right. Next piece I want to look at is my period. And my period, put a 1 there. Your period is what's in front of the x or theta. Oh, sorry, I said it wrong. The period is created by what's in front. So to find your period, it's not going to be 2 pi divided by 1/4. For tangent, it's going to be pi divided by 1/4. All right? Because tangent repeats at pi. Sinusoids repeat at 2 pi. So when I reduce that, or simplify that, I get pi times 4/1. You can put a 1 there if you want. And you end up with 4 pi as your period. Now with these 3 things, I could sketch it really nicely. But right now we're just writing the pieces so that we can sketch it. Next, we want to find this one's midline. So there it is right there. So our midline is right there. So it's y equals -1. Your vertical stretch is a number in front there. So that's a 5. No flip because it's not a negative. And our last piece is right here. That creates our period. So it's going to be pi divided by 2 pi, which if I reduce that, that leaves me a 1/2. And the last problem right here. Let's do the same thing over again. My midline will be a 0 at the end, so it's y equals 0 since nothing's added to it. My vertical stretch is right there, a 3, but the negative reminds me it's going to be upside down. And my period, I could put a 1 in front of here, but right there is what I look at. And it's going to be pi divided by 1/2, which if you simplify that, you get pi times 2/1, which is 2 pi. So that would be your period for the last one.